function e, which is also a log. And we're also going to be doing derivatives of trig functions. So this is just an intro, so you've never seen the e function before. So e is the unique real number such that the value of the derivative, slope of the tangent line of the function, f of x is equal to e to the x at the point x equals 0 is equal to 1, because anything to the power of 0 gives us 1. E is a number such that the limit as h equals to 0 of e to the h minus 1 over h is going to be 1. Sometimes this is referred to as Euler's number. So E is approximately 2.71828182849. So some of you may have heard of that name before, Euler. If not, that's completely fine. So it is an irrational number. So example, a non-repeating, non-terminating decimal. So let's look at the exponential base, the exponential function base e. So we have y is equal to e to the x. So the way this one works is my domain. So you may have never seen this before, which is fine. My domain is the x of the elements of all real numbers, and my range is y in the elements of real numbers such that y is greater than 0. And my equation of the asymptote will be y equal to 0. So the way this is going to look is I have at 0 it's 1, and then I'm going to have my function going that way. So that's what e to the x would look like. Again, this is something new, something you probably haven't seen before, which is completely fine with me. And I don't expect you to have learned this in advanced functions as well. The natural log function, so we call it the log function, is the inverse of the exponential function. For example, y is equal to log of base 10x is the inverse of y is equal to 10 to the x, which means that the function y is equal to e to the x also has an inverse, and that inverse is log base e to the x, which is more commonly written as y is equal to ln x and is called the natural log function. So we get y is equal to log of e to the x, or ln of x. So again, this is the inverse of y is equal to e to the x. So don't forget that. Its domain is going to be x is the elements of all the real numbers, but x has to be bigger than 0. And my range is y is the elements of all real numbers. And here I have a vertical asymptote at x is equal to 0. However, when we have the natural log function, it crosses my vertical asymptote. Okay, so this is going to look like this. So again, this is just a sketch. So this is what my natural function would look like. So again, this is just a basic definition, and it's nothing too crazy, but we will be using this throughout the unit. So now let's look at the properties of my exponential function. So we know that y is equal to e to the x. We know that its domain is x is the elements of all real numbers. However, my domain for the inverse, which is ln of x is the elements of all real numbers, but x has to be bigger than 0. For my range, in my y is equal to e to the x, it is y that has to be bigger than 0, but my range for ln of x is y is the elements of all real numbers. So as you can see, they kind of swap places. So my domain in e to the x is my range in the inverse, and my range in e to the x is my domain in the inverse. So this function passes through 0 and 1, and my function also passes through here through 1 and 0. So the line y is equal to 0 is a horizontal asymptote here. And the line x is equal to 0 is a vertical asymptote for my inverse function. Okay? So again, basic definitions of logs from advanced functions. So remember, if x is equal to b to the power of y, this is called our exponential form, or x is equal to e to the y. If log base b of x, this is called our logarithm form. So we've learned that in advanced functions last year. The notation is read the logarithm of x to the base of b and is introduced in order to isolate the inverse for y. X is called the argument of the log function. So a note to answer the logarithm is the exponent needed on the base b to yield the value of x. So for example, log base 2x is equal to 3, since 2 to the power of 3 is equal to 8. Now, let's go to some basic exponent rules that we learned from probably grade 9 or 10. So if we have e to the p times e to the q, what would our exponents be composed of? Remember, think back to exponent laws. How can we simplify this exponent? Yep. So it would be e to the power of p plus q. Now the power rule for exponents, e to the p to the power of q. What would that simplify into? P times q, perfect. E is equal to p times q. And for division, we get e is equal to p minus q. E to the 0 gives us 1. And e to the negative n just gives me 1 over e to the n. Again, we're just using basic laws from exponents that we learned from grade 10. And we're just applying it to the laws with exponents of base b. However, we also have the laws of logs, which we also learned in advanced functions. So we know the product law, ln of x times y is just ln of x plus ln of y. X over y is just ln of x minus ln of y. Ln of x to the n, you just bring your exponent up, forward, and you get times ln to the x. Ln e is just equal to log of base e to the e, which is equal to 1. Remember, guys, these are just basic laws for our natural logarithm. So we're going to be using these to help us solve the questions later on in the lesson. E to the ln x, this gives me e to the log of e to the x, which just gives me x back. Ln of e to the x gives me log of base e times e to the x, which is equal to x ln of e, which just gives me x. And ln of 1 gives me 0. And then our last law, we have log of base a of x is equal to log base 10x over log base 10a, which is equal to log base ex over log base e of a, which is equal to ln of x over ln of a. So this is called the change of base identity. Okay, so make sure we are keeping these in mind when we go forward with our examples. All right. So let's do some examples. So we're going to be using what we learned, the laws that we learned of our natural logarithms. So for example, we want to simplify a, 9 ln of e. So if we go back to our laws, what is ln of e? What does that always equal? 1. Thank you, Mohammed. So we get 9 times 1, which means that this is evaluated, our evaluated result is going to be 9. Now my next one, we have ln of 4 plus 3 ln 2 minus ln 16. So what is the first rule that we need to apply before we can do anything with product and quotient rule here? Look at the middle term specifically and then try to figure out what law of logs do we need to use for this one. Yep, the power one. So remember, this is the power law. So remember, the power law states, so this is where ln of x to the n is just equal to n ln of x. So this would be ln 4 plus ln of 2 to the power of 3 minus ln of 16. We know 2 to the power of 3 is 8. And now we can simplify. So we can get ln, because we have my addition, we know it's 4 times 8, and divided by 16 because of the negative. So what does my expression simplify to? What would my final answer be? Ln of what? Ln of 2. Thank you, Marge. And we can keep this in exact form. So you can just leave it like that. Okay, and for C, we have E 2 times ln of 3 plus 2 ln of 4. So we get E times ln of 3 to the power of 2 plus ln of 4. So 3 to the power of 2 is 9. So we get E to the power of ln 9 plus ln 4. And now we can use our product rule. So we get E to the power of ln times 9 times 4, which is 36. And because of the rule where it says that E ln of x is just E to the log of E to the x, it just gives us x. So our solution would just be 36. Because of that rule that we have, and if we believe it's 1, 2, 3, 4, 5, the fifth rule. It's okay, Ian. I think I just marked you late. Let me just double check. Yeah, I marked you late. No worries. I'm just gonna. All right. And now let's move on to our next 3 examples. So don't forget, factoring will always be used. Don't ever forget that. You're gonna have to still know how to factor in calculus. So the first example we have is e to the negative x plus x to the e to the negative x is equal to 0. So if we can simplify this, what can I factor out from both terms? Or what's my common factor between both terms? E to the negative x. If I factor out e to the negative x, I am left with 1 plus x is equal to 0. So I have roots now. Basically, I have e to the negative x is equal to 0, and 1 plus x is equal to 0, which means x is equal to negative 1, which is fine. That is a good solution. However, with my next one, in order for me to evaluate, I need to take the ln of both sides. So I get ln of e to the negative x is equal to ln of 0. However, can e to the negative x ever equal 0? No. The reason why e to the x or negative x will never equal 0 is because even if my exponent is 0, it will always give me a value of 1 or a value very close to 0, but it will never give me 0. Which means that this is implying that I need to cross that asymptote for e to the x, which we saw in the graph is not going to happen. So this would be undefined, which means my only solution that would work would be x is equal to negative 1. So whenever we're trying to solve for our solutions, we're going to be taking, unless it's a straight up factor that can be like x equal to negative 1 or x equal to 2. If we have something in terms of e and a solution to the other side, we just need to take the ln of both sides and then use our laws to figure out what our solution is going to be. So the next one we have is 8 minus 2e to the power of negative 2x is equal to 0. Is there a number that I can factor out from that expression? Two. So if I factor out a 2, I get 2 times 4 minus e to the negative 2x is equal to 0. So now I need to isolate for and find my root. So I'm going to try to isolate for e. So if I divide both sides by 2, this is still 0. So I'm left with 4 minus e to the negative 2x is equal to 0. So think of this as algebra, where we have to isolate for e. So in order to isolate for e, what do I need to do next? What do I need to move? Or you can just move, like Muhammad said, the easiest thing to do is just move negative e to the negative 2x over, so it becomes positive. So I get 4 is equal to e to the negative 2x. So now I can just take the ln of both sides. So I get ln of 4 is equal to ln e to the negative 2x. And now because ln e to the negative 2x, that we can use the power rule. So all that does is you get ln of 4 is equal to negative 2x times the ln of e. And based off of our laws that we learned, what is the ln of e always equal to? 1. So I get ln of 4 is equal to negative 2x because this is equal to 1. And now all I need to do is just solve for x. So I can divide both sides by negative 2. So I get x is equal to ln, or negative ln 4 over 2. Now we can get these to the same bases. So does anybody know how we can get 4 to the base of 2? So how can we get 4 in terms of a base of 2? 2 to the power of what gives me 4? squared, 2 squared. So this can then become ln is equal to negative ln of 2 to the power of 2 over 2. Then I can use my power rule again. So I get x is equal to negative 2 ln of 2 over 2. I can cancel my 2's out. And my solution is just x is equal to negative ln of 2. Again, all we're doing is using the laws of logarithms and natural logs. Okay, so I'm going to start the next one off for you, and I want you to see if we can figure this out together. So I got e to the x minus 24, e to the negative x is equal to 2. So let's start off by moving my 2 over. So I got e to the x minus 24 times e to the negative x minus 2 is equal to 0. Because I don't like that e to the negative x, what I'm going to do next is I'm going to multiply both sides by e to the x. So I'm multiplying both sides by e to the x because I want to get rid of that negative exponent. So once I do that, I get e to the 2x minus 24 minus 2 times e to the x is equal to 0. Or if I rearrange it, I get e to the 2x minus 2 times e to the x minus 24 is equal to 0. Now I'm going to have you guys try to figure this out. So think of this in terms of a simple trinomial and tell me what your roots are going to be or what your bracket or factor brackets are going to be. So take a couple seconds to figure this one out. So think of it in terms of it looking like a simple trinomial and try to factor it. Okay, so I got Madge, got e to the x plus 4 and e to the x minus 6. Let's see, did everyone else get that? All right. So yeah, that's the expression. So our factor expression would be e to the x plus 4 times e to the x minus 6, and that is all equal to 0. Now, I need to split it up into roots. So my first one is e to the x is equal to plus 4, sorry, is equal to 0. Move the 4 over. I got e to the x equal to negative 4. So, just based off this expression, will any exponent give me a negative number when it comes to the function e to the x? Will I ever get a negative number? No. So yeah, but remember e to the x, but that function will always be bigger than 0. So this will give me undefined. This is now undefined because e to the x will never give me negative 4. Now I get e to the x minus 6 is equal to 0. I get e to the x equal to 6. Now, let's figure out what we can do. So let's take the ln of both sides. Ln of e to the x equal to ln times 6. We can't really do anything to my right side, but I have the power rule on my left side. So I can take x times ln of e is equal to ln of 6. And ln of e is always equal to what? What is ln of e always equal to? 1. So all I'm left with is x is equal to ln 6. That is my final answer. So is everyone good with this? Oh, so for example 2, if I go up, so remember, when I have a plus, that is the same thing as saying over here, that is the same thing as saying ln of x times y. Okay, so that means you have to multiply. And when I have a subtraction, that's the same thing as saying ln of x divided by ln of y, which is why we have that multiplication and that division in there. Okay, now let's move on to the last 2 examples, 3 examples, yeah. So I have ln of x minus 6 is equal to 0. So I can just move ln of x is equal to positive 6. And then for ln of x, I can just write it as log of e times x is equal to 6, which means that 6, or x is equal to e to the 6. And this is again just using rules of logs. Remember, ln of x can be written as log of e to the x. So don't forget that. That is part of one of the definitions in the second page, I believe. And then the next one we have ln x squared minus ln x minus 6 is equal to 0. So let's use a let statement to make our life easier. So we'll see, let's let a be ln x. So I get a squared minus a minus 6 is equal to 0. Now, what would my trinomial be factored into? Simple trinomial, guys. What would this be factored into? Or factored as, my bad. A squared minus a minus 6. A minus 3a plus 2, thank you. So now I can sub in my lns back in, so I get ln of x minus 3 and ln of x plus 2 all equal to 0. So what I get is ln of x is equal to 3. So if we do the same thing, we get log of e to the x is equal to 3, which means x is equal to e to the 3. And we can do the same thing. We get ln of x is equal to negative 2. We take log of base e of x is equal to negative 2, which means x is equal to e to the negative 2. Or if we don't want the negative exponent, we get x is equal to 1 over e squared. And then the last one we have is ln of 2 ln x is equal to ln of 2x plus 15. So again, I have my power rule, so I get my ln of x squared is equal to ln of 2x plus 15. So I can cancel the lns out, and I'm left with x squared is equal to 2x plus 15. I can make it a simple trinomial again. So what would my factors be in this case? You have x plus 3 times x minus 5 is equal to 0, which means my solutions are x is equal to 5, and we have x, sorry, I put it the wrong way. X equal to negative 3, and x is equal to positive 5. So is any one of these invalid? And why is it invalid, Naj? If you care to explain. Okay, so x is equal to negative 3 is invalid. Because it's a negative. Fair enough. But remember, when it comes to logs, we cannot evaluate any negative numbers because the log of a negative number does not exist, which is why my negative numbers are usually invalid for these types of questions. So that was that for that first lesson. So I'm going to start recording right now. We have 2 lessons after this, which are pretty short. So we should get through this day in around